So today we are completing even more of the SQL 50. So far we have completed all selects, all basic joins, all basic aggregate functions. So today we'll be moving on to sorting and grouping, beginning with question, number of unique subjects taught by each teacher. Let's get rid of the solution. And let me do something else. Alright. I want that to minimize. Okay. So we have a table called teacher with 3 attributes or 3 columns: teacher ID, subject ID, and department ID. We are also told that subject ID in conjunction with department ID is the primary key for the table teacher. Each row of this table will provide you with data that indicates a teacher with teacher ID teaches the subject with subject ID in a given department with department ID. And all we have to do is write a solution to calculate the number of unique subjects each teacher teaches in the university. If you look at input and then an output, we notice that teacher with the ID of 1 teaches 2 unique subjects, while the teacher ID with 2 teaches 4 unique subjects. Let's do the first thing. So obviously we has to be a select. So select, and are we going to have to do any joins? I wouldn't think so, but I'm going to do select from teacher as T just to make my life a little easier. I will do T dot T. No, actually, if I don't need that, I don't think I need to do any of this. Yeah, that doesn't make any sense. So I'll grab the teacher ID. If I could spell teacher ID. And I want the count. What am I counting? I'm only counting distinct subject IDs from the teacher table, right? But obviously I need my alias, so I'll go back up here and I'll do as CNT from teacher. And then I'll group by teacher ID. And let's see what we get. And there we go. Very simple first question to begin with. Let's submit that. Do not remind me today. Alright, cool. Let's go to the next question. Why aren't you showing up? Okay, user activity for the past 30 days. Let's get rid of this. We have our table called activity, and we are told that this table may have duplicate rows. The activity type column is an enumerable category of type open session, end session, scroll down, send message. So basically, activity type can take on one of 4 predetermined values. The table shows the user activities for a social media website, and we should note that each session belongs to exactly 1 user. We have to write a solution to find the daily active user count for a period of 30 days ending on this date, inclusively, which means you have to include this date. And then it says what is the qualifications to say that someone was active, and that is if they made at least 1 activity on that day. And we can return the table in any order. Alright, so let's do, obviously I need my day, so select activity date as day, and then all I need to do is count distinct user ID as active users from obviously only 1 table, so from activity where this one's going to be simple. We'll use the date difference function. We'll copy this date And we'll also pass in activity date, which just means take the difference between this date and the current activity date. Date difference simply takes two dates and returns their values after being subtracted. So if it's less than 30, then yes, it's valid. And activity date is less than or equal to that inclusive date we were talking about, that date. And finally, we will group by activity date. Activity. Whenever I make a video, I forget how to spell. Test.activity. Okay, yeah, somewhere there's spelling wrong. Activity. There we go. Alright, very simple. So we only selected a count of user ID from the activity table where the difference of that date that is a requirement, so this date, and the current activity date is less than 30, and then we just grouped by activity date. Alright, let's submit this. And there we go. Okay, let's move on to the next question. This is product sales analysis. Let's get rid of the current solution of mine and let's begin. Well, first, alright, the third question, product sales analysis. We're given two tables, the sales table, and it states the following. Sale ID and year is the primary key for this table. Product ID is a foreign key to the product table, and each row of this table shows a sale on the product ID in a certain year. And we must note that sale is price per unit. Product table. We only have two attributes. Product ID is a primary key, and each row of the table indicates the product name of each product. And we are required to write a solution to select the product ID, the year, the quantity, and price for the first year of every product sold. And here is a input example with an output example. So for product ID 100, the first year was 2008. Here it is here. Even though we have a 2009, we don't care about any year besides the first year, the numbers sold, and at what price they were sold. Okay, let's think. We could select the product ID, the product we could select the sales product ID, the sales quantity, and the sales price from the sales table. Excuse me, I'm still a little sick. So yeah, we could select the product ID, the quantity, and the price from the sales table. However, we could not select the first year. If we tried to do a product ID, minimum year, quantity, and price from the table, maybe we could get something good. So let's actually try that. Let's select product ID, minimum of the year, quantity, and price from the sales table. So from sales, we'll have to do a group by, let's do product ID, and let's see what we get. And let us do minimum year, and let's remove this and say as first year. And there we go. We get the product ID, the first year, the quantity and price from the sales table. Let's just go ahead and try to run that. But there may be one issue with this. There are two tables here. And the reason why there are two tables here is if something appears in one of the tables, it should appear in the other table. So if I submit this, I may get an error because I may consider a product that does not appear in both tables. Let's see. Yeah, okay, there we go. First test case is already a failure. And is it because I didn't do an order? Am I to do any order? I can return any order. Okay, so let's just go again and see that. This one, okay. Let's see. Okay. So this approach, even though it worked for the test case, it did not even pass the first. Wait, my mistake. Even though it passed the first test, it failed the first test case. So let's see if we can somehow improve this solution. What if I were to just keep this little table here, right? I'll only consider the minimum year, right? So I'll get rid of that. I'll get rid of everything besides that. Okay. So now I only consider the first year as first year from the sales table, and I'm grouping by product ID. Let me keep that up. Let me keep it up there, okay? And I'll comment it out by I will be using it. I could then do the following. I could select s.product ID, s.year as first year, s.quantity, quantity, and finally s.price from the sales table, so from sales. But because I'm using an alias above, I will do as s. I will then do join, and remember that table from above which we were just talking about, I'll just recreate it. I will just select product ID and the minimum year as first year from sales, and I'll group by product ID. And I'll make this table and I'll just call it as J for join. And then what do I want to join on? Well, I want to join on s.product ID. This ensures that initially I have a product ID that appears in both tables. And s.year is equal to, why did I put F? J. And s.year is equal to j.first year. Alright, let's try running that. Okay, that passes, and let's submit and see if we pass our test cases. Okay, cool. Let's go to the next question. Classes with more than 5 students, let's get rid of that, and this one is quite straightforward. We only have one table called courses with 2 attributes or 2 columns called student and class. Both are respectively variable chars, and all we have to do is write a solution to find all the classes that have at least 5 students. Very simple. So select, let me see, what's it called? A select class. Okay, so select class from courses. We only have one table, so that's obvious. From courses, we'll group by class, and now you know how we can do an aggregate function off here, such as say sum, and we could pass in some attribute, right? We could do that, but we could also do the same thing on the bottom after our group by, and that is by using a having clause. So having will run a function. In this case, it will run the count function on whatever attribute I pass. I will pass in student, so it will count the students grouped by classes, and I only want to consider it where the number of students are greater or equal to 5. I could just put greater than 4, but 5 just seems like a better number to work with. And there we go. An abysmal run time. Let's see what is our best one. Having count 1, greater or equal to 5. Oh, okay, yeah, you could also do that. Because you select classes here, it counts as your first select column. So this one matches with that class. But here's the thing. Let me just go away. Majority of the solutions are going to be exactly as mine. As I said in a prior video, what makes a difference in your runtime could be a myriad of things. It could just be you have slow internet. It could just be your device not being as fast as other devices. Other such things. Notice on our second submission, we get a much faster runtime. So don't beat yourself up over having a slow runtime, especially if you're doing SQL queries. Let's go into the next question. We now have to find a follow account. I'll get rid of my old solution. We only have one table called followers with two attributes, user ID and follower ID. And we are told that the two keys together compose the primary key. This table is not in good form, but that's fine. We need to write a solution that will do for each user produce their number of followers. And we have to return the table ordered by user ID in ascending order. Okay, if we look at our followers table, we notice that user ID 0 has a follower ID of 1, user ID of 1 has a follower ID of 0, and we notice that user ID of 2 has two followers, 0 and 1. Therefore, their associated counts are 1, 1, and 2. Okay, so obviously we need to select the user ID, and we need to count something. What do we need to count? We need to count distinct follower IDs. As what is it? Followers count. As followers count from followers. That's wrong. And we simply group by user ID because for each user we are counting the number of distinct followers that appear in the same tuple row as them. Also called record. And there we go. Okay, cool. There's our submission. We will now move on to the next question. And this is biggest single number. So we only have one table. This table may contain duplicates. In other words, there's no primary key. Okay. And then we told the following. A single number is a number that appeared only once in the my numbers table. Find the single largest number. If there is no single number, report null. Okay, so essentially we know that there's a bunch of numbers in this table. We need to consider the number that is both the largest and only appears once. Okay, let me do select num from my numbers. I will group by num, and the reason I'm doing that is because I only want to grab them where a count, which will count the number of times they appear, is less than 2, which means 0 or 1, right? And if I just do that, and if I run this is obviously going to be wrong, but it will reduce my table. Okay, cool. Now notice the only values I have in the numbers table are numbers that appear once. Now, if I wrap these in parentheses, I now have another table with which I can work with, a smaller table that does not contain any duplicates. And then all I have to do is select max of, let's do max, I can spell numbers dot num as num from, and I will indent that and I'll pass in this table. And I need to change you as numbers. And there we go. Very simple. So what we had to do initially was we knew that we had quite a large table here with numbers and we had a few duplicates. So the first thing we did was we reduced that table to be a smaller table that only consisted of numbers that appear less than twice, which means once. Once we have this reduced data frame, all we have to do is return the max from it. Now, remember this, you may not be aware, but whenever you do a select query, it internally returns a table, which means you can work with that select query as a table. And that's why from here, we can consider this a table. And that's how we work with it. Wait, what did that just pop up? Rewrite with, huh? What? Rewrite with Copilot. Why are you appearing there, first of all? Second, do you appear whenever I highlight something? Let's see, if I select a query. Interesting. This is a very weird pop-up. It's annoying me. But anyway, let's go to the next question. Customers who bought all products. Okay. We have two tables again, the bane of everyone's existence, joins. So we have a table called customer with two attributes, two integers, respectively being customer ID and product ID. This table may contain duplicate rows, customer ID is never null, and product ID is a foreign key to the product table. The product table itself only has one attribute called product key and is also a primary key. Okay. Write a solution to report the customer's ID from the customers table that bought all products in the products table. Okay, that's very simple. So we know that we have two tables, customer and product. Only select customers who purchased all products. So in this case, products 5 and 6. Let me think about it. If I were to do select distinct, okay, because I have duplicates, so I'll have to select distinct. I'll have to group by customers to ensure I don't get single customer. But then, okay, the first thing I need to consider is I need to consider how can I grab the number of occurrences in the product table. Select count of product key as total keys, okay? Total keys. Total keys. There should be 2. And wait, unknown column product key. Did I spell it wrong? Oh yeah, I did. Select so as that from product. Right. Should be 2. 2. Okay, that's cool. I now know how I can check the number of total keys within the product table. So then all I have to do next is select distinct. So distinct. What distinct I want? I want distinct customer IDs. From the customer table, I'm going to group by customer ID to ensure I do not get one single output. And I only want to grab it having the count. So I need to wrap this. So count of distinct product key. So it's going to count the distinct product keys. Okay, so only count unique product keys. And the count must be equal to 2, right? Because that's how we get the number of values in the product table. However, if we hard code that in, what happens when we aren't working with a table with 2 values? We'll obviously run into an error. So all we have to do here is create another set of parentheses and then wrap this here into this parentheses. So select, it's going to be count of product key as, I don't think I need to do the alias actually, but anyway, total keys from the product table, right? And if I finally put in that, and if I run this, okay, there we go. Very simple, very straightforward. And there we go. All right.